All right, today's lesson is Chapter 3, Lesson 3, Slopes of Lines. And by the end of this lesson, you should be able to answer, how do you prove lines parallel and perpendicular? That's our lesson essential question. So two of the important vocab terms that you're gonna have to know and use for this lesson are rate of change and slope. Rate of change and slope are actually the same thing, right? They're a ratio comparing the rise the top quantity, the change in the top quantity of a ratio over the run or the bottom quantity of the ratio. So when we use rate of change, we're typically using it in a situation, like in a word problem, right? When we use it to solve an equation or to graph an equation, we use the word slope, but they are the same thing. All right, so rate of change is how a quantity is changing with respect to another quantity. It's just comparing two different things in ratio form. In other words, in a fraction form. So for example, a lot of you teenagers drink lots of soda. So let's say you're able to drink 6 sodas in 2 hours. Right? This is not a recommendation. That is not a good thing to do. It's just an example. So let's say you drink 6 sodas in 2 hours. We could write that as 6 over 2. That would be our ratio. And then we could simplify it to 3 over 1, right? We can divide the top and the bottom both by 2. We would get 3 over 1, which would mean that you can drink an average of 3 sodas per hour. So that would be a rate of change. How many sodas can you drink each hour? Right? The more hours that pass, the more sodas you drink. Slope is the same thing. It's the ratio of the change in the y coordinate. Remember, we use this for equations when we have an x and a y value. So it's the change in y, or the rise up and down, over the change in x, which we call the run. It's measuring our graph side to side. And we always read our graph from left to right, as you guys know. So we always look at slope as where are we going up or down, and how far are we going to the right when I'm traveling up my line from point to point. Okay, so below that, we have a little fill in the blank section here. In a coordinate plane, the slope of a line is the ratio of the change along the y-axis. That's what we were just saying. To the change along the x-axis in between any 2 points on the line. So here we have a picture and we have this graphed line and it shows change in y and change in x. And I highlighted y in yellow and I highlighted x side to side. So here, to get from this point on the left to the point on the right, we would have to go up 3 and to the right, 1, 2, 3, 4, 5, 6. Up 3 over 6, right? 3 over 6, which is 1 over 2. So our slope would be 1 over 2. If we started here and we went up 1 over 2, we should land on our line, and we do. I should be able to do it again. Up 1 over 2. I should land on my line, and I do. Up 1 over 2. Yes. So even if a slope is much bigger, like up 3 over 6, once you simplify it, it's the same ratio. You should still be able to use that same ratio along your line. So it's just the rate that our line is changing. It's going up 1 and over 2 each point, okay? The slope of a line containing 2 points with coordinates x1, y1 and x2, y2 is given by the formula blah, blah, blah. Okay, I want to highlight this. I want you guys to know, and we've already gone over this a little bit this year, but the order of the x's and y's does not matter. I'll say it again. The order of the x's and the y's does not matter. The thing that matters is whatever order you do y in on top, you have to do x in the same order on the bottom. So if you did y1 minus y2, you'd have to do x1 minus x2. If you did y2 minus y1, you'd have to do x2 minus x1. Whatever the order is on the top, doesn't matter what it is, but whatever order you use, the bottom has to be in the same order. If you follow that rule, every single time you'll get the slope correct. Okay, so I'm just gonna write down y minus y over x minus x. Change in my y value, the change in the values up and down, over the change in my x value, or the measure side to side, right? And I'm not going to put the little 1s and 2s because they don't matter. It doesn't matter which ones are 1s and which ones are 2s as long as you keep them the same, consistent. All right, example 1, find the slope of each line. So we're gonna look at each of these graphs real quick and figure out the slope. So here, moving from left to right, I've got this point S way up here. And you have the notes in your folder here, so you can print those out if you need to or take a look at them if you can't see this well enough, but you should be able to. All right, so from point S to point O, what is this, point O? It looks like I'm going from left to right. To get from point S to point O, do I have to go up or down? I have to go down, right? So my first number is going to be negative. How far do I have to go straight down? I'm not going diagonal, I'm going straight down. I have to go down 1, 2, 3, 4, 5, 6, 7, 8 units. I have to go down 8 units. And then I'm not to my point yet, so I have to go to the right. How many units do I have to go to the right? 1, 2. 2 units. That bottom number is always positive because we're always moving to the right. So here, our slope is -8 over 2, which I can simplify to -4. That's the slope of my line, -4 over 1, okay? For this next equation, or this next graphed line here, you can't really see it, but we've got point P and point Q. So there is a vertical line going between these 2 points. Okay, so let's think about this. This is a vertical line. What is our change in Y over change in X, right? Well, our change in Y, there's a lot, because from P to Q, or I could go from any point on this line, I can go up or down anywhere. So our change can be lots of different things. Is there any change side to side? No. So the number on top for this equation, for this line, could be anything. We could go down 1, we could go down 2, we could go down 3, we could go down 4, we could start here and go up. We're not reading it side to side because it just goes up or down. But the number on the bottom, there is no change. It's a 0, right? And in math, in algebra, can we leave a fraction with 0 on the bottom? No, we cannot. So therefore, all vertical lines have a slope of no solution, or no slope, right? Oh, why did I write no solution? No solution. There is no slope. It's not 0, does not exist, right? There is no slope because you cannot have a fraction with 0 on the bottom. It's not a real thing, you can't have it. Yes, there is a line here, but the slope of a vertical line is just none. It doesn't have a slope, no slope, right? There's no solution, doesn't exist, okay? For letter C, for this equation, we're reading from left to right. And here's my point G, and I'm trying to get to point F. So to get from here to here, it looks like it's going up. So I'm gonna have to go up about 1, 2, 3, 4, 5, 6, 7 units. I have to go up 7 units. And then I have to go, I'm not at my point F yet, so I've got to go to the right. 1, 2, 3, 4, 5, 6, 7, 8. 8 units to the right. So here my slope, rise over run, is 7 over 8. And that cannot be simplified. So my slope here is 7 over 8. And I'm done. And then lastly, I have a horizontal line, okay? Well, we know a vertical line doesn't have a slope. There is no slope. We can't write anything. It doesn't exist. It can't have a 0 on the bottom of a fraction. What about this guy, okay? Change in Y over change in X. Change in Y goes up and down. Does our graph, our line here, go up or down anywhere? Does it change and go up or change and go down anywhere? No, so there's 0 change in Y. What about the change in X? Does our line change side to side? Yeah, infinitely, right? We can go from here to here, we can go from here back to here, we can go anywhere on this line. So there could be any number on the bottom. All right, so since I have a 0, does that mean this is no slope also, no solution? No, because the reason we had no slope here is because there's a 0 on the bottom of a fraction and we can't have a 0 on the bottom. But there's not a 0 on the bottom of this fraction. There's a 0 on the top of the fraction, and 0 divided by any number is just 0, right? So in short, a horizontal line always has a slope of 0. A vertical line doesn't have a slope. It doesn't exist. There's no solution. There's no slope because it can't have 0 on the bottom. But a horizontal line can have 0 on the top, and it is just 0. Hopefully that is clear to you guys. All right, for the next section here, we're going to mathematically find the slope between 2 points given. Okay, so here I'm going to mark our y values. I'm going to underline them in purple. I'm trying to keep all my y values purple, and all my x values are red. Okay, so if I want to find the change in y over change in x, I'm going to look at my y values first, -2 and -5. So I'm going to say -2 minus -5. And I could have done -5 minus -2. That's fine. It doesn't matter which order I do it in. But whatever order I do the y's in, I have to do their partners in the same order. Since I started with -2 on top, I have to start with 6 on the bottom. 6 minus -3. Okay, so then when I start simplifying, I get -2 plus 5 over 6 plus 3. -2 plus 5 is 3. 6 plus 3 is 9. And I can simplify 3 over 9 into 1/3. So the slope between these 2 points is 1/3. Real quick, I want to show you, do it on the back of the sheet of paper. I want to show you how it doesn't matter what order the slope goes in. So I did -2 minus -5, but what if I had done -5 minus -2? I could have done it that way, right? The other way, the other order. But if I started with -5 on the top, I have to start with -3 on the bottom. -3 minus 6. So if I flip-flop the order, when I simplify, -5 plus 2, -3 minus 6 is -9, -5 plus 2 is -3, and -3 over -9 is positive 1/3. And that's exactly what I got here. So it does not matter what order you subtract in. Whatever order you subtract in on top, the bottom has to match it. That's the only rule. Okay, for B, the line contains 8, -3, and -6, -2. If we were going to graph an equation of a line, these 2 points would lie on the line. So I'm going to underline my y values and underline my x values. And slope is change in y over change in x. So I'm going to do -3 minus -2 over 8 minus -6. I got to keep them in the same order. I started with -3 on top, so I got to start with its partner 8 on the bottom. And then I can simplify. -3 plus 2, 8 plus 6. That's -1 over 14. And I can't simplify -1 over 14, so I'm done. The slope here is -1 over 14. Make sure your negative sign always floats to the top of the fraction. Sometimes you'll end up with a positive number here and a negative number on the bottom. It's the same thing. It doesn't really matter where you put the negative sign, but when you're done, your final answer should have the negative sign either out front of the fraction or on top. So you could write it this way, or you could write it out front and then 1 over 14, like that as well. But the negative sign can't go on the bottom. Okay, and then 2 more. Slope, slope. I'm going to do it without, no, never mind, I won't. I'm going to underline my y values in purple and my x values in red. Keep everything consistent. Okay, so I'm going to have y minus y over x minus x. I'll do -3 minus 2. It doesn't really matter. Over 4 minus 4. Okay, so one thing I notice here is that both of my x values are the same. They're both 4, right? So what do we think our slope's going to be? What kind of line has the same x values for all its ordered pairs? -3 minus 2 is -5. 4 minus 4 is 0. So there is no slope. It's, oh, that's what we call it, undefined. We call the slope here undefined. I was trying to think of the term earlier. I said no solution. It's undefined. So we have an undefined slope when 0 is on the bottom. And what type of line has an undefined slope? A vertical line. Vertical line. Not that you had to tell that, but just so you remember. Okay, and then D, the last one we're finding mathematically the slope. We have the y values are the same. So over here, the x values were the same, and we got an undefined slope. There was no slope, no solution. Here, our y values are the same. So on top of my ratio, I'm going to have 3 minus 3. And on the bottom of my ratio, since both my y values are the same, it doesn't really matter what order my x values go in. 3 minus 4. And when I simplify, I end up with 0 over negative 7, right? And 0 divided by anything is just 0. So anytime you've got 0 on top of a fraction and you simplify, the answer is just 0. What type of line has a slope of 0? A horizontal line. Easy enough. Okay, and then this bottom part, I went ahead and wrote it in so the notes won't be super long while I write. Parallel and perpendicular lines. Basically what this is telling us is that parallel lines have the exact same slope. Parallel lines have the same slope. If one line has a slope of 2 over 7, then its parallel line will also have a slope of 2 over 7. Perpendicular lines have exact opposite slopes. So if the slope of one of the lines was 1 over 4, or let's say negative 1 over 4, if you flip that fraction upside down and change the sign, that's the negative reciprocal slope. That's the exact opposite. So negative 1 over 4 and positive 4 over 1 are opposite slopes. So they are perpendicular. Opposite slopes are perpendicular. When you multiply opposite slopes together, you'll always get a negative 1. That's another way to check it. The easiest way for me to remember is negative reciprocals. Flip one of the fractions upside down, change the sign in front. If it's negative, make it positive. If it's positive, make it negative. And that gives you your perpendicular line slope. Okay? And then we've got a little review up here at the top. It's kind of a precursor to this lesson. And we've got a few more questions and we're done. So here, I'll highlight these so they stand out. We've got some fractions that we just have to simplify. That's all we're doing. So for negative 3 over negative 12, I can divide the top and the bottom of this fraction both by negative 3. Negative 3 divided by negative 3 is positive 1. Negative 12 divided by negative 3 is positive 4. So this slope is also 1 over 4. A negative divided by a negative is a positive. Okay, then we've got negative 8 over 2. I can divide the top and the bottom by 2. Negative 8 divided by 2 is negative 4. 2 divided by 2 is 1. So my slope is just negative 4. Okay, then I've got C, negative 12 over positive 9. I can divide the top and the bottom by 3. Negative 12 divided by 3 is negative 4. 9 divided by 3 is 3. So I have this answer. This is correct, but I still can simplify. Negative 4 over 3 is like saying negative 3 over 3 and negative 1 over 3 together, right? We're adding those together. So it's really negative 1 and 1/3. That's our solution. And then lastly, D is 0 divided by negative 7. 0 divided by anything is just 0. So the slope of that line is 0. If these had been switched and the 0 was on bottom, negative 7 on top, we would write undefined for the slope. All right, then we've got a word problem here. Determine whether line FG and HJ are parallel, perpendicular, or neither for these points if I graph them. Graph each line to verify your answer. So line FG is our first line. So I'm going to graph that first. F is at 1, negative 3, over 1 down 3. G is at -2, -1. So back 2, down 1. There's one line. Do I have a straight line? I'm going to use my ID. When you're in class, it's like a really easy way to get a straight line, just to use your ID. Because y'all know I can't draw a straight line. All right, and then we have line HJ. H is at 5, 0, over 5, up 0. And J is at over 6, up 3. Over 6, up 1, 2, 3 here. All right, so do these lines intersect? Yes, as a matter of fact, they do. Are they perpendicular? Do they intersect at 90 degrees? Well, the slope of each line has to be, for it to be perpendicular, has to be negative reciprocals, right? So we've got to find the slope of each line. So let's mathematically first find the slope of FG. The slope of FG, y minus y over x minus x. I'm going to do -3 minus -1 over 1 minus -2. And I could have done -1 minus -3 over -2 minus 1. That's fine too. It doesn't matter as long as you keep it consistent. Okay, the double minus turns into a plus. -3 plus 1 is -2. 1 minus -2 becomes 1 plus 2, which is 3. So the slope of line FG is -2/3. The opposite reciprocal to that, the negative reciprocal, would be, if I flip it upside down, 3 over 2, and this one's negative, so it would have to be positive. So line HJ has to have a slope of 3 over 2 if these lines are perpendicular. If the slopes are exactly the same, we know they're parallel, but by graphing, we already know these two lines are not going to be parallel. Since they intersect, now we just want to know if they intersect at 90 degrees. All right, so for line HJ, I'm going to do 0 minus 3 over 5 minus 6. And then simplify. 0 minus 3 is -3. 5 minus 6 is -1. So that's going to give me +3. Are these negative reciprocals? Did I flip this upside down and change the sign to get this? No. Or sorry, this one. I flipped this upside down. I changed the sign. Did I get this guy? No, they are different. This is not the same as this. So these are not parallel. They're not perpendicular. So they're really neither. We can say neither. That would be our correct solution. Okay, you try. There are 2 for you guys to try here. I'm not going to talk. I'm just going to sit here and solve it. So it's going to be quiet for a second while you try to solve. So once we solve these two problems, for A, I have line AB and I have line CD. So the slope of AB was 13 over 25. The slope of CD was 12 over 1. Since they are neither negative reciprocals or the same, then they're not parallel or perpendicular, so they're neither. For B, at line AB, line CD, the slope of AB is 1/3. The slope of CD is also 1/3. So these lines are parallel. They have the same slope. All right, so here we're going to graph a line with the given information. So it says, for example 4, graph the line that contains point 0, 1. We're going to call it point P, and it's perpendicular to, that's important, perpendicular to line QR, and QR has point Q at -6, -2, and R at 0, -6. Okay, so those pieces of information are super important. A problem like this looks super complex, but it really isn't if you take what we just went over, okay? It's just a couple steps is all. All right, so first of all, we're graphing a line that contains point P, and that's all we know is it contains point P. So first thing we want to do is plot point P, and it's at 0, 1. So here is point P. Okay, and then to graph a line, we don't know if the line goes this way or through, down this direction or side to side or up or down. We know nothing else about it other than it intersects this line QR at 90 degrees, right? They're kind of like the Y and the X axis intersect each other at a 90-degree angle. That's what perpendicular means. So our line, on campus, our line is going to intersect through point P and be perpendicular to this line. So the first thing we need to do is figure out what the slope of QR is. Slope of QR. All right, and we know that we have to do Y minus Y over X minus X. So Y minus Y, -2 minus -6 over X minus X, -6 minus 0. We can simplify that. A negative minus a negative becomes a plus. So this is -2 plus 6, which is 4. And -6 minus 0 is just -6. So when we simplify this, we can divide the top and the bottom by 2. 4 divided by 2 is 2. -6 divided by 2 is -3, and that negative is going to float up to the top. Okay, so this is the slope of QR, but our slope going through point P is perpendicular, meaning it has a negative reciprocal slope. So slope of line with P. So it's got to be opposite this. So we're going to flip it upside down, make it 3 over 2. And we're going to change the sign, right? Perpendicular lines have negative reciprocal slopes. So we're going to change the sign. Instead of negative, it's going to be positive. So this is the slope of our line that goes through point P, 3 over 2. Okay, so if we start at point P and we go up 1, 2, 3, and to the right 1, 2, we can put a point. We can do it again. Up 1, 2, 3, over 2, put a point. And I'm going to use my ID again. Oh, I will not show you that picture. A little lanyard thing is all ratty. Ooh, that's not great. So here's my line with point P in it. And if we think about it, it should intersect line QR at 90 degrees, right? Well, I can go ahead and plot QR. It's got a point at -6, -2. So backwards 6 down 2, there's point Q. And it's got a point at 0, -6 right here. So that line, here I will show my picture, would go, oops, that way. Now they don't quite cross, but if I had made this line, this black line here longer, they do look like they'd cross at 90 degrees, right? And that was our goal. We had to sketch the line that goes through point P and it crosses line QR at 90 degrees. All right, we're gonna do another one. Graph a line that contains Q, 5, 1. So our line contains this point. Let's go ahead and plot it before we even get any further. Over 5, up 1. Start at 0. 1, 2, 3, 4, 5, up 1. That's point Q. and is parallel, meaning it has the same slope as line MN, and MN has these 2 points. So first we need to find the slope of MN. Okay, so we're going to use y minus y over x minus x for MN, which is right here. So I'm going to do 4 minus 1 over, since I started with 4 on top, I'm going to start with -2 on the bottom, equals 4 minus 1 is 3, -2 minus 2 is -4. So my slope is -3 over 4. Okay, and my line that goes through this point is parallel, so it has the same slope. So line with Q has same slope, right? So here I have point Q. My slope is -3 over 4, so I'm going to go down 1, 2, 3 over 1, 2. We're going to kind of estimate 3, 4. It should be out here somewhere. Okay, here's a trick. You can go backwards, right? If we always move left to right, that's our slope. So the top number tells me how far to go up or down. The bottom number tells me how far to go to the right. I can go backwards, right? So if I'm going this way, down 3 over 4, if I want to go backwards, I need to go up 3, backwards 4, right? Up 1, 2, 3, backwards 1, 2, 3, 4. This point would be on my same line here. So I can go ahead and draw a straight line through a few different points. The more points you have to guide yourself when you're drawing a line, kind of the more accurate your line's going to be. So our line's going to look something like that going through point Q. If I wanted to graph line MN, I can do that too. It's at point -2, 4, so backwards 2, up 4, and 2, 1, over 2, up 1. And so if I were to draw a line through those, it should be exactly parallel to my line that goes through point Q, and it appears like it is. They appear to be parallel. Cool. Ask me if you need any help with anything, or if you have any questions, let me know. Thanks.